Hello friends, welcome to the part 2 of backpropagation calculation in neural network. So we have discussed how we are calculating the updated value of all the weights here. So we have calculated for W9, W10, W11 and W12. In this session we will calculate for W5, W6 and if possible for W1. So let's continue our discussion. Please stay tuned. Let's say we'll calculate for W6. So I will take only whatever is in green. Okay, so I have written these values. So I have completed this part. So I go for W6 and W5 next. So derivative of L with respect to W6. So rest of the things you can apply this logic and you can do it very easily. So that will be, so now let's draw the, so W6 is contributing to H21, right, and H21 is contributing to sigma of H21. Now sigma of H21 is actually contributing to Y1 and sigma of Y1 and Y2 and sigma of Y2 and then to L, right? So applying the chain rule, what we will have? So it will be, I'll start from the first layer and then I will go to the next layer. So it will be derivative of L with respect to sigma H21 and then sigma of H21 with respect to H21 and H21 with respect to W6. So this is the first layer. Okay. Now what will be this one? So this you already know. So you have two paths. So this one is actually two parts. One is going in this way, so delta L to delta sigma Y1 into delta sigma Y1 into delta Y1 into delta Y1 delta sigma H21. So this is one part. I think I have done a mistake. So W6 is actually contributing to H22. Sorry for this. So it will be, actually I have created this tree for W5. So let's call for the W5. So it is W5. Extremely sorry for this. So but remaining thing will be same. I just mixed H22 with H21. So pay more attention. Sorry for this. So it will be this part and this part. So this is the first one. So you can derive the H21 as this. So do you know these parts? Yes, you know. So delta L by delta sigma y1 you already derive. So it will be this one, right? So I have directly write 0.54. Now do you know this second part? Yes. So this you know, this one. See how you are using the previous calculation. Now what is the last part? So do you know this? No, you don't know this. So let's calculate for this one. So I will calculate in another page so that you can mix up. So it will be delta y1 by delta sigma h21 is equal to delta of delta sigma h21, and y1 is actually W9 into delta of H21 plus W10 into sigma of H, not W10, W11, sorry, H22 plus B2. Right. So taking everything else as constant, so it will be W9 only is equal to 0.9. So let's apply this here. So it will be 0.9. So what is actually? So it will be 0.1207. So let's write it here. So you have delta L with respect to sigma of H21 as 0.1207. Into, now you need to derive this. So this you already know. What is that? You have this formula, right? Let's recall. So any sigmoid function with respect to any variable will be sigma of x into 1 minus sigma of x. So just calculate it here. Derivative of sigma of H21 by derivative of with respect to H21 is equal to sigma of H21 into 1 minus sigma of H21 is equal to 0.786 into 1 minus 0.786 is equal to 0.1682. I just write it there, 0.1682. What will be the last one? So let's calculate. What is that? Sigma of derivative of H21 with respect to W5. So it will be, now H21 is equal to, you know, W5 into sigma of H11 plus W7 into sigma of H12 plus B1. Right. So taking other thing as constant, so you have only sigma of H11. Now you know sigma of H11 is equal to 0.66. So it will be 0.66. So I have written it here, the last part. Derivative of H21 with respect to W5 is 0.66. So it will be actually 0.01. Oops. So these two are fine. I just placed this value in the wrong place. So this is not the value of this. So this is calculated as this one. Okay, so this is only this portion. I missed this portion. So this portion also you know, right? Plus, so what will be delta derivative of L with respect to sigma of Y2? So it will be minus 0.42 into what is this one? So this will be, this is Y2, so this will be this one, right? So 0.58 into 0.42. And what is the last portion? Last portion is Y2 with respect to H21. So let's calculate that one. So delta of Y2 with respect to sigma of H21. So derivative of sigma H21, and you know Y2 is equal to W10 sigma of H21 plus W12 sigma of H22, right? Plus B2. The same way we calculated here, okay? So it will be actually taking other thing constant as W10 is equal to 0.1. So I just made a mistake here, so I need to correct it. So it will be this plus minus 0.0102. So it will be actually 0.1105. So overall value of L with respect to sigma of H21. So let's just put it there. Sorry for this mistake. So it's a long calculation. So irrespective of this, it will be 0.1105. So actually if you calculate these all multiply, so it will be 0.0122. So now what will be the next value of W5 is equal to W5 minus learning rate derivative of error with respect to W5. So it will be 0.5 minus 0.1 into 0.0122. So it will be actually 0.499 approximately. Now I will calculate for W6. So it will be, let's draw the tree. I will draw the first layer only. So it is W5. So W6 to H22 to sigma of H22, and then next part is same, right, but with respect to H22. Okay, let's do it in this way. So you have y1 and y2, and then sigma of y1 and then L. Yes, sigma of y2 and then L. Now you have reached L. So from L if you calculate, so this will be delta L by delta sigma y1 and delta sigma y1 by delta y1 delta y1 by H22. Okay, so you reached here. So this is one branch of the tree plus so this is another branch of the tree. So you reached till here. Now you need to go to the next layer, so it will be easy. Now you need to calculate this portion, and then this portion. So let's calculate it separately. So this is the first layer and you have the second layer. So this will be, do you know any of this? Yes, we know this part. So this part is actually 0.54 and this part is actually 0.54 into 0.46, and this part, so we have already calculated y1 with respect to H21. So if instead of H21, if it is the sigma of H22, so then that will be W11, right? So it will be W11. So it will be 0. W11 is 0.2. So this is the first part. And derivative of L with respect to y2, right? Yes. So it will be minus 0.42 into derivative of y2 with respect to sigma of y2 with respect to y2. So it will be 0.58 into 0.42. Now the last part is derivative with respect to y2 with respect to h22. So instead of h21 it is sigma of h22. So it will be, instead of w10 it will be w12. So we have w12 as 0.3. So it will be 0.3. So if you calculate, it will be 0. This part will be 0.0268 and this part will be minus 0.306. So it will be minus 0.0038. Don't rely on my calculation, please calculate it by your own. So it is a very long calculation, maybe I have mistaken somewhere, but try to understand how I calculated, what is the logic and concept. So this part is now done, right? So I can directly write, so this is minus 0.0038. Now I need to calculate this part and this part. So let's go for this one. Delta of sigma of h22 with respect to h22 is equal to, you know already, so it will be h22 into 1 minus h22. So it will be, what is h22? Sigma of h22 is equal to 0.818 into 1 minus 0.818. So is equal to 0.1488. So just putting it here. So for this it will be 0.1488. Now what is the last one? Okay. So for this we need to calculate. So h22 with respect to w6. So now h22, you know, sigma h11 w6 plus sigma h12 w8 plus b1. So taking other thing constant, so it will be sigma of h11. So sigma of h11 is equal to 0.66. So it will be 0.66. So now putting it again here, so it will be somewhere around minus 0.0003. So now what will be the next value of W6 is equal to W6 old value minus learning rate into delta L by derivative of L with respect to W6. So it will be plus so it will be this. Now let's calculate for the next layer. So we have completed for this layer as well. So hidden layer 1 is also so these weights, so these layer weights is also calculated. So W5, W6. Now we will calculate for W1.